It kind of started with Asher. I was wondering how we can transform his captivating, mesmerizing, impossible physical laws into mechanics for people to play with. In the context of game mechanics refer to how players interact within the game. And gravity mechanics in games are usually acting as a force pulling downward vertically. Simple, but it still can be fun. As early as the initial stages of video game development, thoughts about physical simulation and gravity mechanics in computer space have existed. From Tetris, Full Tilt Pinball, to Angry Birds. In games involving object movement, gravity mechanics are almost indispensable. And of course, our exploration of gravity mechanics doesn't stop there. You can find traces of Escher in the game Manifold Garden. You also discover that the tasks achievable with 6 different directions of gravity are entirely different from what a single vertical force can accomplish. And the most famous of all is Gravity Rush. By its name, you already know it's all about gravity. Gravity is utilized for navigation, combat, and even plays a significant role in storytelling. We seem to have come a long way, but can we go even deeper? Is there more we can do? Or how can we better provide gravity as a resource to both designers and players? To answer these questions, I employed practice-based research as my methodology, creating the game Amtobi. Through experimental practice, I designed game mechanics and iterated prototypes related to gravity, such as magnitude, direction, effect objects, and more, aiming to further explore the design possibilities of non-traditional gravity control mechanisms. So basically, gravity has 2 main attributes: magnitude and direction. Changing the magnitude is quite straightforward. We can set gravity zones or use keys or buttons to increase or decrease gravity, and the way we design this values variation can lead to entirely different gravity control experience. Gravity direction is a little bit more complex. Typically, we can set gravity direction zones where it points in one single direction, similar to the gravity we experience in the real world. Actually, in the real world, we walk on a sphere, and gravity always points toward the center. In game, we can do the same thing, but the size of the sphere and the effective range of gravity zones are crucial variables for these mechanics. Another practice involves triggering gravity direction changes via keys or combo, including reversing gravity, rotating gravity toward the chosen direction, or setting gravity based on normals of surface to enable continuous surface walking. Changing gravity direction allows for a rich variety of movement curves and provides the player with more control and strategy options for navigation. The speed of gravity direction change, whether it can be interrupted, the player's initial movement state, and even the typology of models can lead to different branches of these mechanics. And so far, we have only discussed controlling the gravity of player character. We can create many more mechanisms by manipulating the gravity of other objects in the sense, turning gravity on and off, sharing the player's gravity direction with an object, increasing or decreasing it, or making the player or other static or dynamic objects serve as the center of gravity. To further explore the potentials, I shift from intuitive understanding of gravity to some simple mathematical calculations. Okay guys, here's the thing. In a game, gravity is a vector composed of 3 numbers and can be described using x, y, z value. If we set the starting point of this arrow at 0, 0, 0, the position of the other point represents the magnitude and direction of the gravity. For example, gravity might be 0, 0, negative 0.7 or 0, 0, 0.7, 1, 1, 0 or 1, 1, 0.7. By calling these values, we can interact with almost any object in the sense. For instance, we can use this method to create a directional range. Using range, we can create a true or false condition. We also can use the XYZ value to control different parameters, such as RGB value of materials, metallic, roughness map, or even the blending method between different material layers. Of course, the idea of practice-based research doesn't limit the engagement with the question, and my game was influenced in so many more ways than I can show. But this is the nature of practice-based research. My research has demonstrated the value of exploring and applying non-traditional gravity control mechanisms in 3D video games. These innovative control methods not only offer alternative aesthetic approaches to spatial design in game, but also when accompanied by appropriate caveats or private zones, render gravity a highly effective resource for game designers. The practice undertaking in this project remains quite limited. In the future, designers could consider how to combine sub-mechanism of gravity or integrated gravity mechanism with other gameplay systems. By introducing new interaction rules, they can gradually increase the game's depth and provide players with more ways to interact and explore.